let's return to the topic which we're well known for, which is math with Marty. We gave a problem last week, and we asked the people to consider a golf course 100 yards long, where the people shoot a golf ball and there's no hole at the end of the golf course, there's just a line, and all they're trying to do is get the ball over the line. But the people are terrible golfers. They shoot the ball, they can't quite shoot it 100 yards. Sometimes they get it 70 yards, sometimes they get it 30 yards. They could even get it 99 yards. The length of their shot is a completely random variable between 0 and 100 yards. And we ask, on average, how long does it take them, how many shots does it take them to get the ball over the line? And this question was given to me by Roy Dowling at St. Paul's College at the University of Manitoba. And I had a lot of fun with this problem. I found a way of doing this problem using calculus. And I asked Roy if you had to use calculus to solve the problem. And he said, no, you could do it without calculus. So I figured we got to do this without calculus. So I got down and I found a way of doing it without calculus. And then I asked Roy how he did it, and he showed me another method which was completely off the wall. It went into n-dimensional space, and I don't think I'm quite going to be able to do that method, but it was pretty interesting. Anyways, let's see how we can handle this problem. First, we say the guy shoots anywhere between 0 and 100 yards, which means, statistically speaking, the distribution of probabilities of length of his shot is equally distributed between 0 and 100 yards. Equal distribution. And then you say, you realize, look, he's not going to make it in one shot. Really, the chance is negligibly small that he'll make it in one shot, so we can forget about that. Basically, you need 2 shots to make it. If it's 100 holes on the golf course, no one is going to do better than 200 shots. So the average number of shots has got to be more than 2, because some people are going to make it in 2 shots. And some people are going to need more than 2 shots. And see, this is a surprise to some people, because they say, well, your average is that you've hit it 50 yards. So if your average shot is 50 yards, then 1 shot gives you 50, 2 shots get you 100. So the average score is 2 strokes. That's not the average score. That's the best score you can get. It's a funny thing. And now, just to get a toehold on this problem, I want to invoke the game of Monopoly, where you got a dice, and the dice gives you from 1 to 6, and you start on go, and you throw the dice, and you get anywhere from 1 to 6. So you could land anywhere between Mediterranean and St. Charles Street. And you got an equal chance of landing on any of those properties. And then if you throw the dice again, you also got a shot of 1 to 6, and this could take you as far as St. James Street. But here's a funny thing. You no longer have an equal chance of being on any property. When you take 2 throws of the dice, you are far more probable to be on Ventnor Avenue than anywhere in between, than on any of the other ones. And look, here's how it goes. You got your dice, and there's 6 squares you can get to. 1, 2, 3, 4, 5, 6. And your chances, there's 1 chance of getting on each of those squares. That's after your first throw of the dice. You got an equal chance of being on any of the first 6 squares. Now, after the second throw of the dice, there's only one way you could be on the second square, which is take a chance, or community chest or something, because you would have had to get 1 and 1 again. But as far as getting to the third square, there's 2 ways you could have got here. You could have got here by rolling a 1 from chance, or you could have been on Mediterranean and rolled a 2. That would put you on Baltic. So there's 2 ways of getting to Baltic Avenue. Now, as far as pay income tax, there's 3 ways of getting there, because you could have thrown a 1 off Mediterranean, you could have thrown a 2 off chance, or you could have thrown a 3 off Baltic. So your chances are getting better. Now, as far as landing on this one, which I think is Ventnor Avenue, there's 7 ways you could have got there. There's 6 ways you could have got there. Why am I lying? You could have rolled a 1 off of Ventnor. You could have rolled a 2 off the Reading Railway. There's lots of ways of getting to this square here. But then, as you get past there, there's fewer and fewer ways of getting there. There's only 5 ways you could have got to whatever's the next one, because you would have to be on one of these 5 squares, because if you threw a 2 and you threw a 6, you could have gotten that far to the 8th square. Likewise, as you go on, going up to the 12th square, there's 4, 3, 2, only 1 way of getting as far as that 12th square. So, look, the numbers increase steadily and decrease steadily. And that's your probabilities of where you're going to be after 2 shots. Now let's return to the golfers on this golf course and see where they'd be after 2 shots. After the first shot, you had an equal chance of being anywhere from 0 to 100 yards. After the second shot, it's just like Monopoly. You could get twice as far, but your chances are very small of being at 200 yards, because the only guys that got here to 200 yards would be the guys that shot 99 and 99 twice in a row, which is very lucky. It's just like in Monopoly. Your maximum probability is that you'd be halfway, and a smaller probability that you'd be at either of the extremes. And here again, your 50 yards is going to start to make sense. We said your average shot was 50 yards. Well, in the first thing, that took you here. Then when you got 2 shots and your average shot is 50 yards, then you should be at 100 yards, and that's true. That's your most likely position. Now, we can do this argument twice.